next we have CTO of Federated, Eric Sirion, to give you a little class on Federated eCash Mints 101. Eric Sirion.
Hey, hello. Yeah, it's amazing to see that a whole conference is dedicated to eCash. Like a bit over 3 years ago, like when I started thinking about and working on Fediment, I couldn't have imagined that. Like I was this one guy working on it, and a few people even cared about it at that point. And now look at it, like we have Cashew, we have Fediment, we have a conference of, I don't know, maybe 200 people, all like interested in eCash, and that's just amazing. So thank you all for coming here. And now let's dive into Federated eCash, what it's all about. And thanks to Cashew, thanks to Kalle for giving introduction to eCash earlier already. And yeah, so when we look at eCash systems, what are our goals here? And we already covered like the main thing that people think about when they look at eCash systems these days. It's all about transactions. And transactions should be private. They should be scalable, fast, and also like censorship resistant, which comes from the privacy aspect. But as soon as you build a transaction system, actually, you're not only building a transaction system, you're also building a custody system. And there, the priorities, there are other things that you want to achieve there. You have different goals. The system needs to be secure because you're holding money on there. Like you're not only transacting. Like you want to be able to leave the money on there for weeks, months, years, ideally. Otherwise, it becomes quite cumbersome to work with it. Ideally, it's also auditable. Kalle already touched on that. And last but not least, we also want it to be available because typically systems fail in the worst possible moment of time. So, and we don't want to be at the Bitcoin conference not being able to pay. So, and what I'm claiming is that with Fediment, we can kind of fix these 2 points, like security and availability, or at least improve on them, and still retain all the benefits of eCash systems. So just to give a quick recap of how eCash systems work, you have this entity called the Mint, which issues eCash nodes. And how do we do that? Like a user, you can imagine it as like in the physical realm, a user putting a check for like 1 Bitcoin, for example, into an envelope. And that envelope is kind of magic or made out of carbon copy paper. So when you write on it on the outside, it will be copied onto the inside. And what the user does is puts the check in the envelope that says, the Mint now owes me 1 Bitcoin, closes the envelope, and together with 1 Bitcoin, gives it to the Mint. The Mint then says, yeah, I received the Bitcoin, so I will be signing the check. And like the signature says, the signature is only valid for checks for 1 Bitcoin, so it doesn't really have to know what's inside the envelope. The only thing it really cares about is that there's some check in there with a serial number. The serial number ideally is unique. And then signs it, gives it back to the user can open it, and now has a check signed by the Mint that says later on, the Mint will give you back 1 Bitcoin. And so one day, the user decides, hey, I want my Bitcoin back, goes to the Mint, deposits the check, and the Mint now goes to something called a spend list and checks if the check was ever claimed before. And if not, then the user gets back their Bitcoin. Like that's the most basic way of explaining eCash. And because the Mint never saw the check it signed, it has perfect privacy. So the Mint cannot correlate the 2 events of issuing the check and then the user redeeming the check. So that's like a really, really strong privacy property that and that's why we do eCash in the first place. So, but as I mentioned on the first slide, like there is a problem, and that's the Mint is a central point of failure. And that might come in different forms or might materialize in different forms. Maybe like your local violence monopolist doesn't like you running a Mint. Maybe your mint operator actually decides that they would like to live their life on a nice island somewhere and never look back. Or they are just unlucky and get into a boating accident, I don't know, like the server burns down, whatever. Like there are many ways things can go wrong if you have a central point of failure. So what can we do about it? Let's imagine instead of one mint, we have a bunch of them. And instead of holding the Bitcoin like in a single Bitcoin wallet, we hold the Bitcoin in a multi-sig Bitcoin wallet that's jointly controlled by all these mint operators. And that's basically how you get Fedimint. And you see, that's also how we came up with our logo. So that's what Fedimint's all about. When you look at it from like an architectural perspective, then what you see is we have these mint operators, or we call them guardians in Fedimint, that jointly hold Bitcoin, and in between there's some accounting mechanism, which is the eCash, as I explained earlier. And with that, we have a system where even if a single participant fails, or depending on the size of the federation, a bunch of them might fail, the system keeps working. And that's a great property to have right out of the box. Like you don't have to do any fancy cloud stuff. You don't have to rely on like all the technologies that are available in AWS and Google Cloud to make systems resilient, but then you rely on decentralized parties again. But you can run it on like any server, and it comes with the resilience built in right out of the box without any additional DevOps experience, really. So that's the general idea of federations. We've seen a few examples of federations in Bitcoin already. Like Fedimint was heavily inspired by Liquid Network. There was also Rootstock in the beginning as a federation, and now we have Fedimint. So, but I was kind of glossing over this like accounting part earlier, like this one. Like there's this magic accounting part here, where we still want to use eCash in a federated environment, but I didn't really go into details how that actually works, because the early explanation with the envelope, that doesn't really work if you have multiple mint operators now, or it's at least not clear how it works. Like we can make it work, and I will explain that in a moment. So what we have to do now is we still put our check into an envelope, but now the envelope is given to the different mint operators, like the guardians. And each of them creates a unique signature share. Like each of them has a different key share. And so they all give us back differently signed checks in the envelope that we can then combine to like one single signed envelope containing the check, and we can unblind it again. We can take out the check, and in the end we have the same thing again. And nothing much. We'll have a presentation about that. I think tomorrow at 12:45 p.m. in the planarium, talking about different blind signature schemes and anonymous credential schemes, going into way more detail than I could here. Like there's a lot of fancy cryptography behind it that makes this work. And like that's the core part of Fedimint, what makes it tick. How are we able to take a blind signature scheme and split it over multiple parties and make it a threshold blind signature scheme? And that was also, like in the beginning, the one piece of the puzzle that I was missing before I started, and once I had it, then it was clear, like we need to build Fedimint. So it sounds like that would be all, but no, there's more to it. So you might have noticed I was talking about single peers can fail in the setup, and the system keeps working. So what we actually do here is you only need like T out of N signature shares. Like you don't need all 4. You only need 3 out of 4, for example. And that leaves us with a bit of a problem. Like a clever user could now do something where like they only ask for 3 signature shares for one message, and then the 4th signature share they get for a different message. And they choose different subsets of guardians each time, and they do this 3 times, and they can create eCash out of thin air. So that's why we also use something called consensus in Fediment. Like there's like agreement on which eCash nodes should be signed, like which closed envelopes the guardians should put their signature shares onto. And Joshua will give a talk about that later today in the workshop room at 1:30 p.m. and go into more detail there. So I also said we are holding Bitcoin in a multi-sig wallet. And that kind of means we are not Lightning native as Cashew, for example. Like by default, Fediment doesn't really understand what Lightning is, really. So what we came up with instead is we have this concept of a Lightning gateway. And a Federation can adjudicate smart contracts, or like inside a Federation, you can use smart contracts to incentivize a Lightning gateway to make Lightning payments for you and receive Lightning payments on your behalf. And you will get eCash in return inside a Federation. And that's like the core feature which allows us to interoperate with the whole Bitcoin ecosystem, basically. Like no matter if you're using a Cashew wallet, Phoenix, your self-hosted Lightning node at home, Lightning is the lingua franca for Bitcoin. And how we make this work with these magical smart contracts inside Fediment, Justin Möller will give a talk about that later, I think tomorrow in the workshop room at 11:15. So there's a lot to unpack in Fediment. Like it's a vast system that touches so many areas of Bitcoin, and which makes it really, really fascinating. Now we talked about like the 3 components of Lightning, on-chain Bitcoin holding, and issuing of eCash. So at first, Fediment was only on-chain and eCash. Everything was easy. But then I added Lightning. So now the problem was we had 6 different transaction types, like between each 2 components kind of into each direction. So what if I want to send a eCash to Lightning transaction or eCash to on-chain transaction? These both use the same eCash primitives. And we don't want to repeat ourselves. We don't want to duplicate implementation. So what we actually came up with is a module system where on the same base consensus layer, the same Fediment core consensus, we can implement arbitrary transaction systems, like the on-chain wallet, Lightning integration, and eCash. And the cool thing about it is, it's extensible. You can build your own. And we've already seen that in the wild. Like, Fedi has built something called stability pools, where you can hedge your Bitcoin position and hold like a synthetic version of USD, for example. And that's very powerful for communities that want to use uncensorable money, but cannot deal with the volatility of Bitcoin, because their prices are in US dollars, not in Bitcoin. Some other examples include something called Nostr Mint, where the Federation can sign Nostr nodes on behalf of their guardians, but only if they agree. So the Federation could make announcements on Nostr about what it's up to. And last but not least, someone, I don't even know who it is. Like, that's really cool. It's just a random nym that turned up in our on our GitHub, and they are building prediction markets on top of Bitcoin, on top of Fediment, and that's just amazing. Like, prediction markets are a super powerful tool, and I can't wait to see that in production. So I was talking about a lot about the technical details of Fediment, but what does that give us? What is Fediment all about? And I'd say it's a community custody platform, first of all. It's all about custody, not only transactions. Run by trusted community members with privacy, scalability, and extensibility through the module system and for the benefit of the community. So the next natural step, what people asked is, like, how can I actually use it? And for that, we currently have 3 different client application implementations. Like one of them is Fedi. Full disclosure, I'm a co-founder of Fedi, and we're also sponsoring here. The second one is Mutiny Wallet. That was like a totally independent crew of people integrating Fedimint because it solved a problem for them. Like not wanting to open Lightning channels for each user they onboard. Like they just wanted a ready-to-go Lightning wallet where they don't have the expense of doing on-chain transactions. And last but not least, Webimint, which is just a hack project of mine, weekend project. Don't use it for real money, but it exists. So you might be asking, why are there only 3? Like with Cashew, we saw a whole lot. And the simple answer is 20 minutes built in Rust. Not many people, like, especially on the front-end side, like writing Rust. But very, very recently, we now have a solution for that. And I'm really excited to announce that Fedimint now has a web SDK. So everyone, like, no matter what front-end framework you're using, you should be able to build a Fedimint wallet, build Fedimint into your existing wallet, and we'll be giving 2 talks at this conference. One by Alex today at 12:45, and another one by Ironclad Dev at 3:30 p.m. So that's my presentation about federating eCash systems 101, and I really hope I inspired some of you to build on Fedimint, build modules, build wallets, and reach out to us at chat.fedimint.org, that's our Discord, or on github.com/fedimint. Thank you. Yeah, we can do questions. Yeah, are there any questions from the audience?
Let me get the mic to you.
How does the multiple blind signature scheme work? Like, can you briefly?
So you're talking about blind signature scheme with this threshold blind signature scheme, right?
Yeah.
So we are using a pairing-based scheme called BLS signatures. And they have the great property that like the signature is basically just the private key multiplied with the message hash. And so what you can do there for the thresholding of it, you just split the private key using Shamir secret sharing. Then you sign the message hash, or like you multiply the message hash with each signature share, and then you use the resulting like signature shares in like the interpolation. You just interpolate them with Shamir's secret sharing like combination, and then you get a valid signature from that, no matter which subset of signature shares you use.
It's very clever.
And the blinding is similarly clever. Like you just multiply some blinding factor and then multiply the inverse of that. Like we add both the blinding and the thresholding to BLS signatures.
Thank you so much for the talk. I've got a question. Who determines which mint is part of the Fedimint?
So there are many Fedimints in existence, and it's just a set of people that comes together in the beginning.
So is it a group of mints gathering together, or can you just as a user decide I want some signature from this mint and from that mint? Or
okay, so as a user, you just choose the mints you want to trust with custodying your money, and you join them. But when a mint gets started, then the set of people that wants to run the mint has to be like in agreement that they want to run the mint together. You cannot really join after the fact or leave, or like that would mean setting up a new mint currently.
Static.
Yeah.
Okay.
In the future, we could imagine like adding dynamic federations, but that's a huge task. So
yeah, I understand.
maybe 5 to 10 years.
Thank you.
Yeah, and I saw someone in the audience has experience with dynamic federations. Yeah.
Thanks for the talk. In practical terms, how would you go about running a mint and not get arrested in Europe, for instance?
I mean, first of all, consult your lawyers. I'm not a lawyer. And secondly, like depending on jurisdiction, there are different ways of like running like kind of prepaid systems fully legally. Like for example, when you go to a festival and you buy like festival currency, some of them have like their own little chips for buying like food and drinks, and that's totally legal, right? And if you have a closed system like that, then you could make the same argument, like as long as you can only put money in and spend it, that's not really anything that's currently regulated. And so if you do it in the digital realm, it's not much different from like gift cards or like these festival chips or this festival currency, right?
I think gift cards is the perfect analogy.
Yeah.
Yeah. Obi.
And just to add on that point, there are multiple ways in where you can run federations and mints that are legal within your jurisdiction, but it is jurisdiction based. Happy to talk to anybody offline about that, but it depends on your jurisdiction and your use case.
Any more questions?
Can you speak to kind of the decision or the principle of, specs versus implementation? Cashew has this whole, similar to BIPs, specs, okay, we don't have the implementations follow the spec, but Fedimint is just the implementation is the spec. Can you speak to that at all? Or?
Yeah, so at the beginning, we also had a choice. Do we want to be like a protocol that like anyone implements and we have different implementations, everyone follows the same protocol, or do we just build one implementation? And it turns out Fedimint is just a very ambitious project. Like just federating a mint causes the complexity to go up like 10 times. When I last talked to like someone who looked into like the Cashew code bases, like there are different implementations, I know, but like they're around like 10K lines roughly. Like correct me if I'm wrong there. But like Fedimint, we are already above 100K lines, and just maintaining that one code base for Fedimint implementation, it's already a lot of work. Like if we had a multiple of the resource, then it might make sense to actually have multiple interoperable implementations. But right now, just building one really robust implementation takes precedence over like making it open to other implementations. And I mean, realistically, you can just look at, especially our client implementation, and use the same APIs. Like the APIs are pretty stable because we also have stability guarantees between the client and server. So you could build your own implementation, but it's a lot of work. And I think in most cases, it doesn't make any sense. So just join forces with us. Like we are really open to contributions. If you have any needs in like either Fedimint server, Fedimint client, we can probably accommodate it.
One question here. The web SDK is very exciting. Congrats on that. Is you said is also probably based on Rust, right?
Yes,
So
it's compiled to WebAssembly, and there's the API exposed in TypeScript, I think.
Yeah. So I think it goes into a similar direction as the question before, but would it have been possible to build an entire own client for the web, native one in TypeScript, JavaScript, or is that task so huge that it would make sense to attack it?
It is possible, but it's a huge task. So one problem is the cryptographic schemes we're using are somewhat non-standard. So there's a bunch of custom cryptography that we need to re-implement on the web. There are probably libraries that would make it easier, but then you also need a very sophisticated developer team that understands web technologies and at the same time understands cryptography, which we just don't have really. So and the second part is building the client turns out to be surprisingly complex if you, under no circumstances, want to lose money. Like our first client was really crappy, and like when you shut down your application, your phone at the wrong time, then lost money. So what we built in the second iteration is like a state machine-based system where like each operation that you want to do gets first persisted to a database, and then we try it so long until it succeeds. And like the whole state machine apparatus in the background is probably also 10, 20K lines of code, and just duplicating all of that, it's a lot of work. So I think the focus on one implementation that works really, really well is better than like splitting our focus over multiple implementations and then having less good implementations, because one of them will always be the primary like focus, I think. Like that's how it happens in practice.
Thank you.
It's not really a question. I just want to add something here. So, by the way, I'm giving the consensus talk tomorrow on Fedimint. Eric said that federating our system makes it like 10 times more complex. That was my initial impression as well when I started working on the project 18 months ago. However, these days, if you look at the client, eCash clients, making eCash clients not losing money, making them actually production ready is surprisingly complicated. Not necessarily because of the federation. Our client actually, like the eCash client is not significantly more complex just because the system is federated. It is the state machines that Eric has alluded to are always required, even if the system is not, they have nothing to do with the system being federated. They don't necessarily notice that part at all. I think the more general takeaway here is that an eCash client is a very stateful client, and that is very unusual for a client. So there's a significant engineering challenge there, since usually clients are just like graphic interfaces over like some JSON RPC API, and all the state is on the server side. So that is where like your crash tolerance like comes from, because you know the server state is always consistent. Now you need to manage all of this on the client side, and there you run into significant challenges. For example, like this makes a client much more complex. I think, like, therefore, even if the system weren't federated, we would like gravitate towards a solution where we have like one client in Rust, which is on the order of like 30, 40,000 lines, and then we do JavaScript bindings. Yeah, because eCash clients by themselves, doing them production ready is just, yeah, surprisingly complex. Yeah, that's all.
Yeah, thanks for the additional clarification. Like the server side is more complex because of the federation, while the client side is just inherently complex.
Yeah, for us, still the client is much more complex than the server side, even though the server is federated.
Yeah, I mean, we try to keep the server side simple because it's much harder to change. Like that's, I think, another real challenge with any live deployed system, that you don't want to break it for existing users, right? So you have to be very careful with the changes you make, and the more you can move into the client side, the easier it gets, kind of. Yeah, if there are no further questions, then thank you very much for attending my talk, and I hope we see a lot of eCash hacking this weekend.
Ladies and gentlemen,